So linear and quadratic functions, and there's only 2 sections in here. So when you go into the media, you can look at the rest of it, but you're only doing section 3.1 and 3.2. So 3.1 is the linear. It's a function, and 3.3 is the quadratic function. And you'll see we've done everything. And kind of nice about the linear is that we already did the arithmetic, and remember all the arithmetic series turned out to be lines. And so that's nice because we can use our knowledge from the arithmetic series to come up with the equation of the line, to come up with the function. Of course, we could use point slope formula, we could do anything we want. It's nice to actually show off a little bit and verify that you can get the same result a couple of ways. And then you know for sure, check, I got that question right. I don't have to worry about, did I get this one right? I know I got it right. So so let's talk about our linear functions real quick here. So we're talking about f of x equals an mx plus b, right? So of course we've got if m is not 0, this is an oblique, right? It's moving at some horizontal. If m equals 0, f of x equals b is a horizontal line, right? And of course we know lots of things. M is y2 minus y1 over x2 minus x1. We know y minus y1 equals m times quantity x minus x1. That's the one I'd really encourage you to use. And we also know that a sub n is a sub 1 plus d times n minus 1, right? So from our arithmetic sequences and series. So there's really not much more to do here. I think this guy's really hinting to us about what we're looking for. We're looking for the x's to change by delta x, the y's to change by delta y, and to be no variance on that. Of course, delta x and delta y can be different, right? But they should be consistent, right? So let's go right away to some problems, okay? And give me a second here to try and... yes, thank you. The lockdown browser test password is 123ABC. Oh my God, so many emails from the school. Nice. So first question is I give you a linear function. Find me the slope. Find me the intercept. Verify a points on there. Graph the function. I like to think of this. So I got y equals 4x plus 6. Right. This is homework 13, number 1. And so, like when I'm teaching this to middle schoolers, I say this is where I begin, and this is how I move. Right? So I'm beginning at 0, 6. 1, 2, 3, 4, 5, 6. and I'm going to move up 4 over 1. So up 4 over 1. Right? So, and I'm always moving left to right. So real simple way. Right here, of course, the slope is 4. The b value is 6. The y-intercept, and I hate the fact that the computer will just say the y-intercept is 6. Where it hits on the y-axis is 6, but it's a point, right? Kind of thing, but that's just me being picky about it. So pretty simple. So what's our slope here? 4. The y-intercept, it says type an integer, but that drives me crazy, but who cares? So 6. I say 0, 6. Graph the function. So it's a nice way to graph this is I just have to pick the line with 2 points on it and pick the first line, right? And then pick my second line. What did I say? Go up 4, 1, 2, 3. Oh, sorry, 0, 6 was my first one. Sorry. So I want to clear that. So I had 0, 6, right? And I went up 4 over 1. And then save it, and then check the answer. Determine the average rate of change, and that is what? What are they asking for there? What are they asking for when they ask for average rate of change?
The secant line?
A secant slope. Yeah.
The secant slope,
secant
yeah.
slope. Yeah. Yep. Nice. And so we already know, right? We've done enough of these linear ones. Is there going to be a linear one on your test? No. Is there going to be a linear one on your practice study guide? Yes. So, but it's too easy. But we know our average rate of change on any 2 points is 4, right? And that would come from our secant slope. Oh, this one's tough. Is this increasing or decreasing? Right? So this is definitely increasing. I'm sorry.
It's constant.
Yeah. Well, it's asking, is the function? Yes, I agree. The slope is constant. And so in that case, in Calc 1 thought the derivative is a constant. But and the derivative is a positive, and that means my function is increasing. And so that's what they're asking about. Is the function increasing? Am I walking uphill as I walk on that line, left to right? Right? So anyway, sorry, it's so offensive. Let's do this one. Y equals 1/5 x minus 2.
1/5.
Yeah, so the slope is 1/5. I think the most important thing we do is the graphing, right? So this is homework 13, number 2. Y equals 1/5 x minus 2. And so m is 1/5. The b value is -2. Watch how I generate my table, right? The table's kind of nice here because I figure out what delta x is, right? And delta y is 1. So I want my table to be moving by 5s in the x direction, right? So 0, -2 is my intercept. And then my table 5, 10, 15, 20. I'm going to move my x's by delta x, my y's by delta y. So -1, 0, 1, 2. So a real easy way to generate a table for a linear is to move your x's by delta x. Delta x we always make positive, and then delta y will either be positive or negative depending on the sign of the slope. But when we graph it, we certainly know we're starting at 0, 2, and I can pick any of those points, or I could walk the line. I could walk the slope. So move up 1 over 5. Move up 1 over 5. 2, 3, 4, 5. And there's my next point, right? So I've got the 0, -2. I've got 5, -1. So nice, easy, quick way to graph lines. This is feeling like a review and very easy for everybody, or is anybody stressing? And you can chat it to me. Just feeling, should feel like a
Pretty
review.
straightforward.
Yeah.
Professor, can you explain the table really quickly?
Yes. So where did I get the table? If I'm just thinking like middle school level, I'm going, okay, well, what x's should I plug in there to make things, to get rid of fractions, right? So I'm looking at that line, 1/5 x minus 2. It's very clear that if I put in fives, multiples of 5, every time the fraction will cancel and it makes it simpler. But if I know my slope is delta y over delta x, and that's 1 over 5, then I'm getting from this that delta x is 5. So it's easiest to just move my x's by 5. 0, 5, 10, 15, 20, 25. 0, 5, 0, negative 5, negative 10, negative 15, right? But then as I move my x's by 5, I've got to make sure I move my y's by, as I move my x's by delta x, I should move my y's by delta y. But certainly I could just plug the numbers in for x and then solve for what I get for y. Right? I don't have to see the pattern, but I'm hoping you do see the pattern. Nice, thanks, Paris. I think that's it for this section. There's a horizontal line. This is good. So determine if this is a linear. So I'm looking at my delta x's, right? So am I taking nice steps in the x direction? 0 to 1 to 2 to 3 to 4. Does that sound like I've got a nice pattern for delta x? Yes. Okay, now I want to see, can I find a pattern for delta y? So it looks like I'm adding 2 every time. I'm sorry, subtracting 2 every time to my y values. So I can see that this is arithmetic, right? This is arithmetic. So I have what? 1, 2, 3. I have 1, 2, 3. And my y's are negative 3, negative 5, negative 7. So I can already get my nth term almost instantly, right? A sub n is my first term plus that common difference times n minus 1. So I get negative 3 minus 2n plus 2. I get negative 2n minus 1. And so there's my nth term, or better yet, y equals negative 2x minus 1. There's my y equals mx plus b. Right, so we did all of this with the arithmetic. It's a nice way to verify that you can do one of these arithmetic nth term type problems. And again, you'll see all of that on the review when you do the review. How we doing there? Nice. So there's a couple of like that on there. One of them turns out to be linear. One of them turns out not to be linear. I think there's 2 or 3. This one might be a tricky one. 0, 1, 2, 3. Okay, nice pattern for delta x. 6, 6, 6, 6, 6. I'm adding 0. That's arithmetic. I'm adding the same thing every time. And this one turns out to be a horizontal line, right? This is really simple horizontal line. Y equals 6. And the last few questions here are just, can you find when the two graphs equal each other? If you can find when the two graphs equal each other, then you can find when one graph is above the other or one graph is below the other. So let's do one like this. So I've got y equals 3x minus 2 and y equals negative 2x plus 3. This is question 8. Y equals 2x I'm sorry, y equals 3x minus 2 and negative 2x plus 3. And so I'll call one of them y1, one of them y2. And of course I'm going to use my calculator. I can do a table as well, right? So, but I want to get an idea. So I'm going into my y equal button. Does anybody want to see me do this on my calculator on the screen here?
Yes, yeah, that could help.
Yeah. So here I am in my TI-84 emulator showing on the screen. I'm putting in the two functions. First function was 3x minus 2. Second function was negative 2x. Oops, I put a minus, not a negative. Negative 2x plus 3. And when I watch it graph, it will graph the first line first, y1 first, and y2 second, right? So I can see clearly on my picture. I could zoom in, etc., but I want to get a basic idea of what these things look like when I graph them. And if I need to go back to the calculator, just let me know. So y1 was something like this, and y2 something like this. And of course, I'm interested in the intersection, right? I'm interested in when the x's are equal and when the y's. When the two x's are equal to each other, right, and the two y's are equal to each other. When they're hitting at the same x value and the same y value. And so what do I get? I get 3x minus 2 should equal negative 2x plus 3. So it looks like I get 5x equals 5. So x is 1. And once I get the x value, I can plug it back into either equation and get the, right? And so y1 at 1 is 3 times 1 minus 2. So 1. So the point where they cross is 1, 1. Now, what's interesting to see here is that the x is 1 is cutting my domain into two pieces of interest. Okay, when x is 1, my domain to the right is of interest to me, and the domain to the left is of interest to me. What happens, right? So we'll say y1 equals y2 at x equals 2. At x equals 1. I'm always interested in the domain pieces. y1 is greater than y2 on what domain? So when is the red curve above the purple curve is what it's asking. And that's on from 1 to infinity kind of thing, right? When is y1 greater than or equal to y2 on closed 1 to infinity, that type of idea. So they're asking for subsets of the domain here for the rest of these types of problems. And I feel like I might be kind of going too fast through this stuff, but we have so many more difficult things to do. And this is just an essential review topic that I want to make sure I look at it at least. But you'll see when we're doing inverse functions and when we're doing the trig and when we're doing all of this other stuff, I need the time. I need the class time when we get to these more difficult topics. But I'm hoping you communicate with me or come visit at office hours, right? I haven't had a single office hour visit yet. I mean, I don't care. I'm getting paid anyway, but I want to help, right? I want to help you. If you need help, I want to help. So, and again, the office hours that I have listed on my schedule, you don't need an appointment. You can just drop in. Just like a deli, if I'm already making someone else's sandwich, give me a minute, you know. And then if those office hours don't work for you, you can schedule a different time with me via email. You have an embedded coach to use. I'm hoping he can. Oh, yes. Could you explain the y1 greater than y2? Yes. So this when I see this, right? When I see this piece, I'm a geometry person. That one says to me, the red graph is higher than the purple graph. And so where is the red graph higher than the purple graph? Over here, right? And so I'm asking, what are those x values? What are those x values when it's true? When is the red graph above the purple graph on the interval from 1 to infinity exclusive, right? And that's kind of a nice one to do on Desmos. You can do them, of course, you could do them on your calculator, but you got to look it up because it's too much typing for me. But if I go to Desmos, I can play around with it. I'm going to share my screen in a second here. So I have y, y equals 3x minus 2. And I can restrict my domain by x is greater than 0. Oh, x is greater than 1 I wanted, right? Because that's where I got the intersection. Give it an extra. I got too many symbols in here. There we go. And then the other one was y equals negative 2x plus 3. And again, I want to restrict from x is greater than 1. And you can see, again, the red graph is above the, in this case, the blue graph. Right? So the domain we're talking about is x is greater than 1. Nice. I mean, you can do all of this stuff on the TI, but it's just the typing is horrible. But do a quick Google search, graphing piecewise, you know, on the TI 83, 84, you'll find YouTube videos, you'll find just the keystrokes that you should type in, and very simple. All right, that's it for 3.1. So nice and easy. Not going to hurt you to do it. I mean, really, your focus is be ready for the test, right? But if you're caught up in everything else, you're right. Dinner's on the stove, laundry's done. You certainly can do homework in 3.1. It's not going to hurt you, right? It's not going to get in the way of the brain for this test. So let's see, what if we look at 3.2? I think 3.2 is really good for us to do because you're definitely going to have at least one question with a quadratic that you're going to complete the square with and get it in vertex form. So let's take a look at homework 14. So this is quadratic functions. So of course we're talking about f of x equals ax squared plus bx plus c, right? What can you tell me? Anything you want to share with me about what you know about this particular function? Anything you know about it?
The quadratic equation?
Fine. Okay,
Yeah.
yeah, so good. So x-intercepts, right? X-intercepts are going to come from 0. I'm sorry. Uh, uh, x equals minus b plus or minus square root of b squared minus 4ac
minus 4ac
all over 2a comma 0, right? Easier if we can factor it. Easiest is factoring. Next easiest is complete the square. Final thing you would go to is quadratic formula. Maybe, you could debate on the switching the last two, but factoring is really important. The y-intercept is going to come from what?
From C.
Yep, 0 comma c. Nice. If a is greater than 0, right? The range is going to come from a to infinity. I'm sorry, x sub y sub v to infinity. And if a is negative, right, if that leading coefficient is positive, it opens up. So I go from my vertex up. And if a is negative, then the range is coming from minus infinity, comma, y sub v. And I'll show you what I mean by that in a second. But of course, we already know that f of x is a times x minus x sub v quantity squared plus y sub v, right? This is that vertex form that we got by completing the square. And x sub v, y sub v is the vertex, right?
Sorry, Professor.
Yes.
On the range,
Yes.
shouldn't, like, if a is less than 0, shouldn't the shouldn't it be yv comma negative infinity?
Sure.
Or does the order really matter?
Yes, the order matters. So when I know that the parabola opens down, this is the highest point of my y values. And I'm always using the smallest number to the largest number. So when I'm reading intervals, right, remember I'm reading the interval on the y-axis. So my highest point is y sub v, my lowest point is negative infinity.
Right.
Right, and so I always read them left to right, smallest to largest. So that.
Okay.
Yeah, so there are languages that we read right to left or top right to bottom right, or but for us, we're reading everything left to right.
Okay, got it.
Yeah, and it's weird that the left to right here is down to up, but we just have to realize our y-axis. We're just rotated to get our y-axis. Of course, the domain is everything, right? The domain is all reals on these. And there's certain subtleties of will I have a real intercept, a real 0, or do I have complex zeros? I'm really skipping complex numbers. I'm not doing any work on complex numbers this semester, just to save a little time, since it doesn't happen in Calc 1 anyway. But if you have to do a little work on complex numbers on your own, you should have had them, I think, in Math 50, certainly in high school. So let's look at a couple of problems here, because that's everything we need to know. And I say the newest thing that maybe we couldn't do that well yet until last week was complete the square. But at this point, you should have been practicing it and getting it done. And don't fight me on it. You're going to have to do it in Calc 1. You're going to have to do it in Calc 2. You're going to have to do it in Calc 3. So why not just get it done now, right? You might hate it already, but you're going to lie to me about that. You're not going to say you hate it. You're going to make it a game. Try and come up with a pattern. Try and come up with your own method, right?
Man, I sure do love completing those squares.
Joe, I'm right there with you, man.
It's just so much fun.
I agree. I am
Totally know how to do it and all that.
Yeah, good for you.
Yeah.
So let's look at one here. Here we go. This is number 4. 2x squared minus 8x plus 4. Will you write that down for me so I don't have to look back? So I'm looking at 2x squared minus 8x plus 4. I don't know why I can't remember stuff like this. But this is homework 14, number 4. So I had f of x equals, was 2x squared? Help me.
Minus 8x plus 4.
Thank you. So I want to graph this on my calculator, but I'd like to be able to graph it without the calculator. So the easiest thing is to put it in vertex form. So our process is to factor out the leading coefficient from the first 2 terms and leave that last term. And so I would call this guy B, and I'm calling this one K, right? So K is negative 4. Half of K is negative 2. And half of K, quantity squared, is positive 4. So I'm going to add 4 on the inside and subtract that 4 on the outside. And notice that the 4 on the inside is actually 2 times 4. So that's why I subtracted 8. How is everybody there? Is anybody okay? Is anybody panicking? I'm not hearing anything from you. See, if we were in a damn class together, I could look at you and I would know. But I can't. I'm really angry today. I don't know why. Oh, my baseball team lost. I don't know. Not really. I don't care. My cat died. I don't care. I hate cats. Sorry. My cat didn't die. I don't have a cat.
You're scaring me.
He's going off the edge.
I'm losing it. Come on, who's with me here? Are we okay?
I think it makes sense.
But just in case, can you explain it again?
Yes. So my process, be a good robot, eat your batteries. Factor out the leading coefficient from the first 2 terms. Find the value of K afterward. That is the new coefficient of the X term. Get half of it. Square it. Add it on the inside, subtract it on the outside. And that's where we're at right now. I think the trickiest part here is how it changes with that leading coefficient. I got to make sure I multiply by 2 to the 4 I added inside and then get rid of that number, right? So I added the 4 on the inside, which means I actually added 8, so I have to get rid of 8. Now, next step, this piece that I factored will always turn into, without fail, x plus half of k quantity squared. So x minus 2 all squared. So I can go back to my Algebra 1 factoring thing, right? What 2 numbers multiply to positive 4 and add to negative 4, negative 2 and negative 2. I can do that, but don't waste your time, right? Just know that it always factors into x plus half of k quantity squared. And so now I'm in my vertex form. So now I'm in vertex form. And what's nice about this is I know it opens up, right? I know it has a vertex of 2, negative 4. 1, 2, 3, 4, right? And notice where my transformation is happening. I'm taking that 1 by 1 box, right? Can you picture that 1 by 1 box? But I'm doubling the height because I'm multiplying on the outside by a 2. So I'm doubling that box, and then that corner, now that new corner, is where my parabola is at, right? So I can get the vertex is at 2, negative 4, and my other point is 3, negative 2, right? Because of that multiplier by 2, right? This transformation, that transformation piece I did. So I've got a horizontal shift to the right, a vertical shift down, and a stretch in the y direction. Now, can I just plug points in and verify these points? Yes. And should you do that? Probably, right? So, what else do we want to find? We want to find our intercepts. Let's find our intercepts. So obviously we know we have a y-intercept of 0, 4, right? But what about our x-intercepts? I mean, I'm going to use complete the square. I've already got it squared, right? So I've already got my complete the square, and I'm setting it equal to 0. So x minus 2 quantity squared is equal to 2. So x minus 2 is equal to 4. Sorry, plus or minus 2. What did I do wrong? I did something wrong. Oh, yeah, plus or minus square root of 2. So x equals 2 plus or minus rad 2. Those are my intercepts. And I, do that as you wish. If you're someone who wishes to do that as quadratic formula, that's fine. I'm not going to stop you from using the quadratic formula if that's what you prefer to do.
Sorry, Professor. How did you get the last
Yes.
the last line?
So
x equals 2 plus or minus square root.
Yeah. So first of all, I moved the 4 over, right? I divided by 2. So x minus 2 quantity squared equals 2. I took a square root, and when I take a square root, I got to do plus minus on the numerical side, right? So now I have x minus 2. Square and square root kill each other. So x minus 2 equals plus or minus rad 2. And now add 2 to, remember I'm solving for x, so I add 2 to both sides. So add 2, add 2.
Oh,
Yep.
got it.
Yep.
Got it.
Yep.
Okay.
Yep. And I skipped 6 steps there. But like I'm saying is, we all know how to find the roots of a quadratic.
Right.
If you can factor it, factor it. Otherwise, take your choice. Use your complete the square and or use quadratic formula, right? So that's totally up to you. Whatever you can do faster, that's what we want. We have to be able to do this stuff quickly so that there's room for the calculus. All of this past algebra has got to happen quickly at this point.
All right. Thank you.
Yes, of course. So anyway, I think that's it. We talked about everything. Let's see if I can get to an interesting one. I think we should do another complete the square. Oh yeah, let's do this one. So let's do this quadratic, and let's answer everything. But let's answer everything. Let's anticipate what they're going to ask, right? What are they going to ask? They're going to ask for A, B, and C. They're going to ask, does the graph open up or down? They're going to ask for a y-intercept. They're going to ask for x-intercepts. They're going to ask for the vertex. They're going to ask for the domain. They're going to ask for the range. So, but let's do this one right now by complete the square. Let's get it into vertex form. Because that's the only thing I'm worried about with everybody on this. I'm not worried about you using the quadratic formula. I'm worried about the vertex because I see it. My Calc 1 students can't do it, and I see it. My Calc 2 students can't do it. I'm like, what the hell? It's easy. You just got to practice it. Like bowling is easy, but I hate it. I don't like things where I have to change my shoes or wear someone else's shoes. So, but it's not difficult, but you have to practice, right? And you don't practice with the gutters up, right? You allow yourself to make mistakes so that you can really learn the process. All right, we're going to factor out a -2. and we're going to find the value of k. I get k as 1. Anybody agree with me? Anybody else there with me?
Yeah.
Good, so half of k is 1/2. And if I take that and square it, I get 1/4. So I'm going to add 1/4 on the inside, but you can actually see I'm actually getting a negative 1/2 there. So I have to add 1/2 to cancel it out. I can, at this point, is everybody with me here?
Don't you multiplied the 1/4 by the 2 outside?
By the -2, yeah.
-2, so that's why it's plus 1/2 and
Exactly.
not gotcha.
Yep.
All right.
Now I could think about this, right? I could think about this here, highlighted in blue, as what two numbers multiply to a fourth and add to 1? And of course it's 1/2 and 1/2. Or I can remember that Robert said, I'm sophisticated now. I don't have to think of it. I can just think of x plus half of k quantity squared. So x plus 1/2 quantity squared. And then what is that? Minus 7/2. We've taught you how to factor. We don't need to. If you can just understand why you're completing the square so that you get a perfect square, then why bother trying to factor it? Now, is it a good idea to double check? Yes. It's a good idea to double check. And so now my vertex is what? Minus 1/2 minus 7/2. Remember my little saying, x's behave inversely, y's are direct. X's are inverse, y's are direct. So I take the opposite of that x value, and I keep the y value to get my vertex. It's our domain of f. Go ahead. Yes, Grace, tell me.
Where did you get 7/2?
Minus 4 plus a half. Minus 4 plus a half is minus 8 over 2 plus a half, so minus 7/2.
Professor, I'm not so sure how you got from x squared plus x plus 1/4 to x plus 1/2 squared.
Okay, so because I know you're at this level, I just told you. Okay, so now you have to go back and double check. Does that make sense to me? Is it always going to be x plus half of k quantity squared? The answer is yes. How do I know that? My teacher told me. Okay, but can I double check it? Can I double check it? Yes. And remember what I did is I had to say what two numbers, in this case fractions, multiply to 1/4 and add to 1. So 1/2 times 1/2 is 1/4, and 1/2 plus 1/2 is 1. So that's how we factor, right? So there's that. Yeah. So, but you can see, I'm saying to you, at this time, I already know you don't know how to do that. So just go right away to x plus half of k quantity squared.
Okay.
Yeah.
Got it.
Put it on your formula sheet, right? Put it on your step-by-step for completing the square. So my domain is everything. My range for f is what? It opens down, right? So the highest point is minus 7/2. So I know my range is from minus infinity to minus 7/2 inclusive, right? And of course I'm going to graph I'm going to graph it, right? So I know it's doing this. I know there are no x-intercepts, right? Because it starts below the x-axis and opens down. So if I did try and use the quadratic formula there, I'd get complex numbers, right? Square roots of negatives. I think that's the hardest thing we've done in chapter 2 or 3 is complete the square. But if you practice, I'm telling you, it'll be very simple. It's like that first time you're learning to ride a bike and all of a sudden you get it. Same thing's going to happen here. It's going to just feel right, right? It's going to click, and you're going to practice. You're going to graph. You're going to double check. Go find some other nerd to explain it a different way, etc., etc. Right? You will get it. You will get it. So I'm just going to show the completed one there, and I don't even know if they're asking us to graph this one, but oh yeah, they did. No x-intercepts, there is a y-intercept, right? Axis of symmetry I didn't talk about, but of course it's x equals the x coordinate of the vertex. X equals x sub v is the axis of symmetry. I didn't write that down anywhere. X equals x sub v is the axis, right? So wherever the vertex is, that vertical line, x equals x sub v, that's my axis of symmetry, right? I'm reflecting about that. I think the coolest thing to maybe look at, because we're done here, we've done everything here, is what do A, B, and C actually do to the graph of a quadratic? I think we know what A does. I think we know what C does, but not many students know the effect of B. You can do this on Sketchpad, on Desmos, but I get a little bit more power if I use a program called Sketchpad. Geometer Sketchpad. It's not free. You can always download it and do a demo with it, but then you can't save anything. I think it'll allow you 30 minutes of work on it at a time. And there's probably good apps out there, but it's just I'm so comfortable with this one that I'm just gonna so I'm gonna put sliders down. Okay, I'm gonna put sliders down A, B, and C, just anywhere, not really anywhere, but, and I want to take the value. I want to find the x value of A, the x value of B, and my x value and my y value of C. And I'm going to create from that a function. So you don't need to do this, by the way. So ax squared, just watch me and listen to me, plus bx plus c. And so I can see that if I move the value of c, it just takes my whole graph and move it up or down. If I move c up, because it's a y value, right? If I move c up, the graph goes up. If I move c to negative, the graph goes down, right? So same, what did I do? Sorry. If I move A, right? If I move my slider A, when A is large, remember what A does. A is that amplifier. So it's stretching out my box in the y direction if A is larger, right? If A goes to 0, oh my God, why can't I move this stupid thing? If A goes to 0, I don't have a quadratic anymore, right? If A is 0, it's a line, right? If ax squared is 0, it's now linear. It's now an mx plus b. But if A is negative, you can see now the graph opens down, right? So A is negative, the graph opens down. A is positive, the graph opens up. C just moves the whole graph up or down because it's just a y value. But the interesting thing is, what is B, what does B do, right? So when I change the value of B, let's see if you can see what's happening. And I'm not using my mouse here for some, I'm having a hard time with the mouse. So, but look at, as I make B go to the negative, notice where B, right, as B is negative, it's doing something to the curve. It's just translating it. It's not transforming it. It's not manipulating the shape. It's just moving the shape, right? And do you see where, how B is moving the shape? You see where B is moving the shape. Anybody? You see what B, the value of B is doing to the shape? It's taking, it's not stretching the curve out, it's just sliding it. And where is, I'm asking you, where is it sliding it?
I don't know if I'm crazy or something, but it looks like it's like moving it in a curve.
Yes. Which curve?
A parabolic curve.
Yes. Which parabolic curve? The same one I'm starting with, but negated. So if you can see that if I take the vertex, and I'm working on the vertex right now. Give me 1 second. Here's my center. I want to transform. I want to dilate by a marked ratio. Oops, sorry. Marked ratio. Sorry. Center. Transform by marked ratio. Dilate by marked ratio. Does it give me my marked ratio? Damn it. Oh, I might have to, transform mark scale factor. There it is. So transform, we dilate by my marked, there it is. So here is my, my x coordinate of my vertex. So construct perpendicular. So there's my axis of symmetry. That's the x coordinate of the vertex. And I want to, just rotate this, transform, don't give me 1 second, rotate 90 degrees, good, construct a perpendicular, good, put the point there, mark my scale factor, don't listen to me, and now translate this, dilate by my scale factor. And there's my vertex now. So there's my vertex, and I'm going to trace it. Display, trace. Okay, now I'm going to move B. So if you see, if I move B, you can see the exact same parabola of what I'm moving, but it's tracing out itself upside down. Right? It's tracing out.
Okay. Got it. How does that happen?
That's a great question. And That's a kind of question that I would, if you were doing like pre-cal with honors, and so some of you should think about doing Calc 1 with honors, that would be a kind of question you would try and answer. How is B doing? Well, how is B doing? What is B doing? How is it doing it? And how can I show that that's what it does? So, and it's not an easy answer, but it's a great question. Great questions don't always come with great easy answers. Like Einstein's question was, if I'm driving at the speed of light and I look in a mirror, can I see myself? Or is the mirror moving faster than my reflection would get there, right? And this question alone, that simple question, led to this theory of relativity. So
Very easy.
yeah. So anyway, we're done today. That last bit was just me. I know it's like, what the hell's he doing? But just trying to get you to see what the value, how you change B and what does it do to the curve of ax squared plus bx plus c. So anyway, we're done. Everyone know what they're doing. Try and get that review done by Wednesday so you can ask questions. If you're doing homework, ask questions. If you can do all the homework, you can do the test. It's not like the test is all of a sudden has a lot more difficult things on it. Okay. So I will see you Wednesday or office hours today